Okay, this is Friday, April, see, 2nd, 3rd, 4th, this is April 6th. Friday, April 6th, the 5th day that I haven't been here. Miss you guys, and hopefully you're doing this review because this review is just like the test. So make sure you are doing this review and understanding it. Don't just copy it. Make sure you're understanding it because the test is just like this. All right, so it says right here in the directions, approximate solutions to 4 decimal places when necessary. That means it's straight calculator. When it says 4 decimals, you can do the calculator. So we're going to go 3. And then for those that have the new calculator, we're going to go alpha window, 5. And we're going to put in a 2. And we're going to put in a 4. And we're going to press equals. And the answer is 6. For those who do not have the new calculator, it's 3. And then I would do parentheses. And then I'd go log 4 divided by log 2. Like that. Parentheses. You get 6. You could have done this one by hand because log base 2 of 4 is 2 because it's 2 to the what power is 4? It's 2. So this whole thing is 2, so it's really 3 times 2, which is 6. This one has the special property. This has a base 5, and that's a log base 5, so they're inverse operations because this is exponential, and that's logarithmic, and they're canceled, and your answer should just be x. I'm not even sure you can put that in the calculator, but let's try. 5 raised to the alpha window 5, base 5 of x. No, it doesn't work. Don't do it on the calculator. It gave me a 2, and the answer should have been x. So you said the special property that the 5's cancel. And this one, log of 10 cubed, is the answer is going to be 3. That's because this is base 10. It's a common log, base 10. These 10's cancel. And your answer is just going to be the exponent 3. If you would have punched that in the calculator, just go log 10 cubed. Oops, get rid of that parenthesis. Make that a big parenthesis. And you get 3. Okay. Rewrite the exponential equation as a logarithmic equation or vice versa. So this is a log equation, and we're going to write it in an exponential equation. So if it gives it to you like this, we're going to write it like this. If they give it to you like this, we're going to write it like this. So obviously this one has a log in it, so it's a log equation. So we're going to swoop. So we're going to go 2 to the 4th equals 16. That's all you have to do. They don't want you to simplify it because this is just a true statement. This one is an exponential equation. Notice there's no log in it. So this one's exponential, and we're going to write it as a log. So when you do the logs, be careful. There's basically 3 boxes that you need in a log. The exponent goes over here, and the base goes here. What it's equal to goes here. So in this problem, the base is 3. That goes here. The exponent is negative 4. That goes over here. And what it's equal to, 1 over 81, goes right here. So when you rewrite this, make sure if you're using lined paper, some of you had problems with this on your quiz, that the base goes below. The 1 over 81 is not an exponent. It's the same line as 81, and the negative 4 is the same line as 81. Use the change of base formula to approximate each logarithm. You do not have to do this unless you have an old calculator. If you have a new calculator, just do your alpha window. Okay, so this answer, if you're doing alpha window, 5, 7, 14. So it's 1.3562. If you have the old calculator, it is log 14 divided by log 7. Same answer. This one, nothing fancy here. Everyone, no matter what calculator you have, can punch this one in. It's the natural log, so it's the key that's down here, this one right here. Oops, you can't see. This key right here. See it? Natural log. Press that key, and then 0.059. For a negative 2.8302. Answer. Use the properties of logarithms to write each expression as a single logarithm. So now we're going to condense. to 1. So to condense, first of all, you have to make sure you have the same base, which we do, and you're going to write log base 5 once. Now we're not adding 12 and 6. What are we doing? We are multiplying them. 12 times 6. And if you can multiply, you should. 12 times 6 is 72. But I'd accept this answer too, probably. This one, anything that has, okay, so we're going to get this to 1 logarithm, but before we can do that, this 3 looks like the only number that's out front. This is the only one that's out front. We're going to move this 3 right there, make it log base 7 of x cubed. So before we can make this 1 logarithm, you have to get that any factor that's on the outside moved as an exponent. So now we're going to write this as a log base 7. Starting with x cubed, we're going to multiply the next thing we see, which is a y. The reason we're multiplying is because there's a plus sign. And then we're going to divide, what we see next is there's subtraction, and we're going to divide by x plus 3. So I don't like how I wrote that, so I'm going to write it again. So it's log base 7 of x cubed y divided by x plus 3. And that's a good way to write it. So these are some remember things for your tests. To solve equations, so we're going to be solving in the next 4 problems. When you solve, when you have a single log, when a single log equals a number, it means a single log's on one side, you're going to swoop. When a single log equals another single log, you're going to drop the log from each side. When x is in the exponent and bases are the same, you're going to drop the bases and set exponents equal. When x is the exponent with different bases, take the log or natural log of each side. So, in this first problem, number 10, it looks like we have a log on each side. Okay, so when you have a log on each side, that's right here, when a single log equals another single log. So we have a single log equal another single log. We're going to be dropping the log from each side, but you can't do it yet. Does anyone see a problem with this? I do. There's some numbers out front that you cannot drop the logs if there's these outside numbers. So we're going to rewrite the left side as log base 3 of x to the 1/2 equals log base 3 of 3 squared. Now we can drop the log from each side because we've cleared the numbers out front. So it's like right here, this is when you drop the log. So you're going to set x 1/2 equal to 9. Now there's a couple ways you can do this. X 1/2 is really the square root of x. Some people like it like that. And how do you get rid of a square root? You square both sides. You could have done that from this one. You could have squared both sides from this step. Either way, you're going to get rid of this. If you square the 1/2, you're going to get 1. If you square a square root, you're going to get the 1. So this is going to be x equals 81. Because 9 squared is 81. On this one, you have a single log. So that's this first one. When a single log equals a number. This is a single log and it equals a number. We're going to swoop. But before you can swoop, you have to know what the base is. What is the base of log? It is 10, because that's called a common log. So take 10 and raise it to the 1.4 power. Set it equal to 18x. Now to solve for x, what do we have to do? We should get rid of 18. So x equals all of this. So let's punch that into our calculator because you don't want to leave that ugly answer. So we have 10 raised to the 1.4. Press equals and then divided by 18. And that is 1.3955. Number 12. Notice there's no logarithm in this problem. So if there's no logarithms, the first thing you want to do is, can I get 4 and 15 in the same base? Can I write 15 in base 4 or base 2? The answer to that is no. So if you can't get these to be the same base, you're going to do this one right here, where it says when x is the exponent with different bases, x is the exponent with different bases, you should take the log or natural log of each side. So we're going to take the log of each side. Now, remember, we're solving for x, but right now x is an exponent. So how can we get the x not to be an exponent? We bring it out front. That's called the product. That's called the power property. I can't talk. Okay, so we have this. Now again, we're solving for x. It's x times this. So to get rid of multiplication, you divide both sides by log 4. And then we're just going to simply punch this into our calculator. So we have log 15, close your parenthesis, divided by log 4. And it's 1.9534. And this problem, this is just like the last problem. I cannot get 3 and 5 in the same base. So we're going to take the log of each side. This time your x is part of a sum. So I'm going to put it in parentheses. We're bringing it out front, but you just got to remember it's two terms so that they don't lose each other. You should group them together. Keep them bounded together like this out front. Now we're solving for x. So I would divide both sides by log 3. And you get x plus 2 equals whatever log 5 divided by log 3 is, which is 1.46. Okay, so the 7 is going to round the 9 to a 0, and the 0 is going to round this 4 to a 5. So it's 1.4650. And then we're going to subtract 2 from that. And our answer is going to be negative 0.5350. That's your answer. Okay, first page of the review is done. Ooh, a lot of solving on this page. Get ready. All right, so in this one, we have logs, 3 logs. 3 logs is too many. Just remember that. 3 logs is too many. So we got to condense on the side that has 2 of them. So we're going to make this 1 log. And since there's a plus sign there, we're going to multiply x to x plus 1. Like that. Once you get a single log on the left and a single log on the right, you can drop your logs. So this is going to be x squared plus x equals 12. Whenever you have an x squared, it means you have 2 answers, and one side has to be equal to 0 so that you can factor. So we're going to subtract 12 to this side, and we're going to factor. So we have x and x plus 4, and oops, I think that's going to be a minus 3. Factors a negative 12. Or 4 and negative 3, or negative 4 and 3, and we want them to equal 1. So we chose 4 and negative 3. Positive 4 and negative 3 equals 0. And I'm out of room. So x plus 4 equals 0, and x minus 3 equals 0 is negative 4 and 3. You have to remember, though, that with logarithms, usually you have an extraneous root. That means an extra answer that doesn't really make sense in the problem. So if you plug a negative 4 into this x right here, it's going to be null and void because you cannot take the log of a negative number. So the negative is not going to work, but the 3 should be good. Log of 3, 3 plus 1 is 4. Just to show you that you can't take the log of negative 4, there's the log of negative 4. Oops, it gave me an answer. That's because I'm in my complex number mode. Let me go to my real mode. Let's try that again. Log of negative 4 is supposed to look like this. Error, non-real answer. Okay, you can't. That's why negative 4 doesn't work. So your answer is just 3. So in 14, you have a single logarithm. If you have a single logarithm, you're going to swoop. So this one we drop the logs. And this one we're swooping. So we have 10 to the negative 2.3 power equals 4x plus 1. We're solving for x, so subtract 1. I'll put this thing right here in the calculator at the end. So we have negative 10 to the negative 2.3 minus 1 equals 4x. Then we're going to divide by 4. So x equals all of this. So let's punch that in. So we have 10. I want you to be able to see this. So we have 10 raised to the negative 2.3 power. Press right arrow. Then we have minus 1 equals, divided by 4, negative 2.487. Nope, you know what? This is wrong. It's negative 0.2487. That's your answer. 15. We have two logs, but they're on the same side, so you can't drop them. You only can drop them if one's on the left side and one's on the right side. These are both on the same side. Whenever they're both on the same side, you want to condense into one. So we're going to write log base 3 once. And then we have x plus 4. And then this minus, that means you're not multiplying. It means you're dividing by 9 equals 1. So now you have a single logarithm. So this is when you swoop. So we're going to go 3 to the first is equal to x plus 4 over 9. Now, this is over 1. So we're going to cross multiply. This is 27 equals x plus 4. And then if you subtract 4, you get x equals 23. 16, we have an e in the problem. So that means we're going to take the natural log of each side. So whenever e is involved, we want to take the natural log of each side. Once you take the natural log of each side, that releases this exponent out front. Like you cannot bring this exponent out front unless you have a logarithm written in the problem. So we're going to bring 2x minus 5 in parentheses out front. Now, does anyone remember what natural log of e is? If not, punch it in the calculator. Natural log of e is just 1. So this whole thing is just 1. So basically, it's just still like having 2x minus 5 equals natural log of 4. We're solving for x, so add 5 to both sides. Natural log of 4 plus 5. We'll punch in the natural log of 4 in here in a second. And the last step is divide by 2. So x equals natural log of 4 plus 5 equals divided by 2 for an answer of 3.1931. $17. I'm sorry this is so long. So 17, there's no logs in the problem, but I think I can get this in the same base. I'm going to try this without using logs. 1 over 216 is 6 to the what? Look at the chart over there. Look at your 6 column. Look at the chart on the board. 6 cubed is equal to 216. So I'm going to make that 1 over 6 cubed. So then I can make 1 over 6 cubed 6 to the negative third. Drop your bases. X minus 1 equals negative 3. Add 1. X equals negative 2. What do you guys think about that one? I like that one. But if you don't like that, you can take the log of each side. You could take log of 6x minus 1 equals 1 over 216. You could bring the x minus 1 out front. You could divide by log 6. And then add 1 to all this. You could have log 1 over 216 over log 6, and then add 1. Try that in your calculator. You'll get negative 2. All right, this one has two logarithms, but they're not on different sides. They're on the same side. So whenever they're on the same side, you want to condense to 1. So we're going to have log, and then what do you do if you have x plus 5? It is really going to be multiplication, 5x equals 2. And then we're going to swoop. Then we're going to swoop. So we have 10 to the second equals 5x. Hello? Yes. All right, is Luke's game canceled yet? Okay, I'm in the middle of a video, so there you go. I'll talk to you. I'm in the middle of a video at school, so all right, bye. Sorry about that. All right, so this one has a single logarithm on the side, so we're going to swoop, but we notice I filled in an e right here. So we're going to go e to the second equals 2x plus 3. Solving for x, let's subtract 3. So we have e to the second minus 3 equals 2x, and then divide by 2. So x equals all of this. So let's punch that in the calculator. So to get e, you're going to press second division. There's my e. Squared. E squared. Minus 3 equals divided by 2. The reason I press equals all the time is because this has got more than one term, so you have to group it. So if you don't press equals before you press divided by 2, then you're going to have to put parentheses around this every time before you press divided by 2. So my trick is just press equals after you do the numerator. That means it totals out the numerator before you press divided by 2. That's your answer. So this one, I think we can do this one without logarithms because I think we can make 256 in terms of a 2. Maybe you don't know. I think 256, let's try it. What's 2 to the 7th? 2 to the 7th is 128, so it's not that. So it must be 2 to the 8th. There it is, 2 to the 8th. I just recognize that number. So 256 is 2 to the 8th. So let's make this 2 to the 8th. Drop your bases and set 8 equal to 16x. Divide by 16 and x is 1/2. If you do not think that you're going to be able to do that 256 to 2 to the 8th, don't forget you can take the log of each side. Release the 16x out front. Divide both sides by log 2. So punch that in your calculator. Log 256 divided by log, what I say, 2. And you get 8. And then divide by 16, and you still get the 1/2. So you can do it either way. Or, I'll put an or there. Do it either way. So the next one, we have 3 logarithms. It's kind of like the one we did up here in 13. When you have 3 logarithms, you got to condense one side. So we're going to condense this down to one side. So we have log x plus 4. Oh, we're not multiplying though. This is minus, so we're going to divide by x minus 3. Careful with that. I must multiply. But when you subtract, you're really dividing. Now that you have a single log on the left and a single log on the right, this is when you can drop your logs. And you're going to set x plus 4 over x minus 3 equal to 5. But we're going to write 5 over 1 so that we can cross multiply. So you have x plus 4 equals 5 times x minus 3. For x plus 4 equals 5x minus 15. Let's get our x's on the same side. 4 equals 4x minus 15. Add 15 to both sides. And divide by 4. So 19/4 or 4.75. We'll go with 4.75 for your answer. 22. We've got 2 numbers on the side that are same base. Do you remember what you do when you have the same base? I hope you can't see this problem. When you have the same base of 4, you're going to write 4 once. And you're going to add the exponents. So 2x plus x is really 3x equals, and I think we can write 64 in terms of 4. 64 is 4 to the 3rd. Look on the chart on the board. So now we have 4 to the 3x equals 4 to the negative 3, because if it's in the bottom, we can move it to the top. Drop your bases, set your exponents equal, and x is negative 1.